Okay. Good afternoon. This is probability. So the same today was still do matrices. I don't know if because I have somewhere to go. So if there will be time, maybe I thought of three topics. So these are the first two. We must do it. If there's time, then I'll do the third. This is probability. I'll start with this activity. So what is probability? Probability simply means the number of chances that are available for an event to occur. So that is just how you can understand probability. The number of chances that are available out of a total number of outcomes that are possible for a particular event. So now there are some characteristics that I'll be giving you for probability that with this you don't need to solve. The answers come out and they are self-explanatory. So the first thing is to the effect that the probability of a sure event or an event that is certain, the probability is 1. The probability of an event that is sure, that probability is 1. Now, when an event is not certain, in fact, I will not say uncertain, but I will say the probability of an impossible event, an event that can never occur, the probability is 0. What is the meaning of these two phrases? It means probability has a range. The probability of an event will vary between 0 and 1. So probability can never be bigger than 1. If they give you a question in probability and you solve, your answer is 1, 2. Your answer is 1, there's no problem. It means that it's an event that in fact there are no other possibilities. Yes, if your probability is 5, stop and then go back. Or just forget, or you leave the hall because you might fail. Yes, probability cannot be more than 1. So when I put this, I'll add this to it. This is the range, meaning that probability can be less than or equal to 0. Sorry, can be greater than or equal to 0, and then can be less than or equal to 1. Cannot come out of this range. Take notes.
So those are greater than signs now.
This is less than or equal to. Less than or equal to. So it means probability must be less than or equal to 1. And 0 must be less than or equal to the probability of an event. It's okay. Now, let's go now to that activity and then we look at it. Here, they say find the probability that you live forever. Now tell me, is there anybody on earth that will live forever? No. So this is never possible. This is the probability of an impossible event. So what's that probability? 0. 2. The probability that 3 people win a presidential election.
0.
Is it possible that in a year, in a country, 3 people, they win one election? No. So that probability is what? 0. The probability that 2 divides 4. What's 4 divided by 2? 2. So it's divisible now. It means 2 can divide 4 now. And so what's that probability? 1. Because it's very sure. There are not 2 possibilities. 2 must divide 4. Are we good? So now, that was just activity. Now the lesson begins. So I'll be giving you in subheadings, and as usual, I'll just be giving you what you need to know. First thing first, I want you to take good to know. Just write as a small heading. Good to know. Good to know. Yeah, these are things that you need to know them. That's why I call them good to know. Good to know. Number one, we are defining. Number one, probability. So, what is a probability now? Is there any try? From what I've said here, what do you think? I know before you did not know you. Now with what I've said, what can you say is probability?
Probability. This is the chances.
Chances?
This is a chance. Let me try and define it in two ways.
Okay.
Yeah. From this is a phrase which shows either
write this probability. Or you have to say something. You say it.
Probability is the ability for or the chances an event can occur.
Good. That is better. You write this. Probability refers to the number of chances that are possible or available for an event to occur. So we're defining, good to know, we are defining probability. Probability. We started with a small activity, so this is just something. This is where we are beginning. Yes. Probability, we are defining it. The next one we are defining is experiment. Remember I said I'm giving you just what you need to know, right?
Yes, sir.
In fact, but it's not just going to be what you need to know because you need to know everything. So I'm giving you everything.
Or stipulating.
No, if I say I'm giving you what you need to know, you will start thinking that meanwhile it is not like that. Okay. So you have defined probability now.
Yes, sir.
Now go ahead to experiment. An experiment is an action. It's an action. Or a process that leads to results. Or you can say that leads to a set of results. An experiment is an action or a process or an activity that leads to a set of results. Then the next thing we'll define is outcome. An outcome is a possible result of an experiment. An experiment is a set of activities or actions or process that leads to a set of results. Now, an outcome is what? A possible result of an experiment. Now, sample space. Sample space. In probability, we represent it with S. Sample space. A sample space, I hope we're there, is a set of all possible outcomes. Sample space S is the set of all possible outcomes. Events E is a subset of the sample space. When I say subset, I want to believe that you know what we mean by subset. It means it is a small part of the sample space.
Say what? Is the subset
Of it is a subset of the sample space.
So you're saying like this way? Sample space.
Pardon?
You are done with sample space?
Yes, a set of all possible outcomes. That's the sample space.
Defining the event now.
Yes, we are now on events. And I said an event is what? A possible, or an event is just, let's just say a subset. Subset of the sample space is okay. Represented with E, put in bracket. Then, now, that last two things that we'll not talk about, we have favorable result and we have favorable outcome and unfavorable outcome. So just add favorable outcome, then you also add unfavorable outcomes. Those are good to know. It's okay. Yes, favorable outcome. It is an outcome that satisfies the condition for the event. A favorable outcome is an outcome that satisfies the condition for the events. On the other hand, now you can define unfavorable outcome without issue.
That satisfy the condition of the event.
Yes, for the yes of the events. Satisfy the condition of the events. We are good, right?
Yes, sir.
Right. Now, after defining all those things, still under good to know, take a hyphen. You know what I hyphen? Still under good to know, right? We're talking about the activity. First hyphen. The probability of a sure event is 1. Then the next hyphen, probability of an impossible event is 0. Then the last hyphen, you write this. Probability varies, it ranges between 0 and 1. You still write it. This one is my note, you have to put it. So, now, the probability formula. After putting those three, you put the probability. You put the probability formula. I hope we are good now. Yeah, hold on. Now, under the probability formula, given the sample space S, the sample space S, and events E, given a sample space in bracket S, comma, and events in bracket E, and the number of times the event occurs in bracket N. The probability of E denoted PE is given by the probability of E denoted PE is given by, you now come down, you write this formula, P equal to number of favorable outcome over total number of outcomes. You can put that in a beautiful box. The probability of an event E is the number of favorable outcomes. Here under favorable outcome we said those are outcomes that satisfy the intended result or they satisfy the purpose for the event or the condition for that event. So now we take the number of favorable outcome over the total number of possible outcome. It gives us the probability of that event. Example. Or let me say exercise. Exercise. Find the probability. Sorry, wait. If a die is rolled, find the probability of getting a 3. If a die is rolled, find the probability of getting a 3. That's exercise. Just do that fast and then let's see how to continue. Answers are there. Go, what's your answer?
The amount is 2.
Your answer is 2. Okay. His answer is 2. What's your answer? It's 2. Okay. So it's like majority will win. What's your own answer? Anyway, let's work with these ones. And your answer is 2 and you're happy.
I'm not happy, sir.
You should be crying by now. If you're not happy, you should have been crying by now. What was here? This number 3 point. I said you should write what there? I said you should write this probability, right?
Yes, sir.
Less than or equal to 1. Greater than or equal to what? 0.
Say it again, what say?
It means that probability must be less than or equal to 1, but greater than or equal to 0. In other words, probability lies between 0 and 1. It can be from 0 up to 1, cannot be more than 1, and can never be less than 0. You can never have a negative probability, and never will you ever have a probability that is greater than 1, like 5, 2.
My answer is half.
That's that. Okay. 3 now. Answer is 3.
No, sir.
5.
Half.
I wanted the majority to win, but now that it's okay, there's no problem. So now let's go ahead and solve, okay? Let's go ahead and solve. We said sample space. Sample space is a set of all the events, okay? Yes. Then now, we have a certain number or a number of all the possible outcomes. Yes. And then we also have a number of times that the number of favorable outcomes. So these are possible outcomes, favorable outcomes. It's okay. For every event, there are possible outcomes, there are favorable outcomes. So now, where the favorable outcomes is equal to the total number of outcomes, we have probability of 1. Now, who has never seen a die? This die is to play Ludo now. He has 1. He has dots on it now, black dots. 1 on the other side, 2, 3, 4, up to 6. Right? And so, what does it mean? What are the total number of outcomes? We want to get a 3. How many 3s are there on that die?
1.
1 3 now, it's only 1. On one side you have 1, on the other side you have 2, on the other side you have 3, you have 4, you have 5, you have 6. So if you want to see the number of sides that have 3, it's only one side. Are we there?
Yeah.
So now, the probability of this event is what? The number of favorable outcomes over the total number of possible outcomes, 6. We are okay. I should explain again.
So say it die. Explain. No, I mean explaining it die. I understood the question. My problem is it die.
You know, you play Ludo now.
Yes, okay.
You show what you do, what die you
Yes,
die.
I haven't drawn it on the board.
Come on, come on, draw.
I draw it. You say you have 6 sides. How will you draw the sides?
Yeah, sure, yeah.
1. This side like that. Yeah. 4. This side 5. The other side is lacking.
Another side is lacking.
It's okay.
6.
This is just more answers or
The number of favorable outcomes.
and then the end.
Total number of possible outcomes. So now, immediately you copy the solution, you write what types of events. Types of events.
So big N is the number of favorable now.
Total outcome.
Yes, total of outcomes. Look, come back to where you wrote all this. Okay? It's okay, leave it. If I remember, I'll give you again. I wanted to add something. Yes?
This and then that one that you get M on the floor like that, how do you call it?
It's still that thing. It's still that.
No, I mean the round one.
That one that is round. There's no probability in that one.
But how do they call it?
I know. Am I a child? You're asking what children roll the floor. Are you asking about the 98-year-old human being? Even him, I'm not sure. Do you know what she's talking about?
I don't play that one.
But I've been seeing it. The things I don't know the name. If God love was here, he would tell me. This the name.
No, Godson. The name Godson.
Godson, Because they have died inside Rapper, they hide it. If you come and see, you go and throw, they will still find a way, they will still get. I don't know whether they are buying it or I don't know.
It's a small N is what?
Listen, why did we take our total number of outcomes to be 1? Why did we take our total number of outcomes?
No. Total number of outcomes was 6. Because there are 6 sides of a die. Number of favorable out of the 6 sides. Favorable outcome is 1 now. Total number of outcome is 6 now.
So how did you know that favorable outcome is 1?
For all the sides of a die, for the how many sides? 6 sides of a die. How many sides have 3 dots on it? 1. That is the favorable outcome. Yes. It's okay now. So types of events. events. So please bring your books. Let me mark through anyway. Let's just continue. But remind me at the end, I have to mark them. This exercise now.
Papa 6, 1/6.
Okay. Type of events. Number 1. Certain events or sure events. The probability of this kind of events is what?
1.
1. Two, impossible events. The probability of this kind of events is what? 0. 3, mutually exclusive events. Mutually exclusive. I'll explain. When they say 2 events are mutually exclusive, it means that they cannot occur together. It means if one will occur, the other one will never occur. It's just like you have crisis with a classmate or a coursemate, and in case you're coming to class and you see that person in class, you'll go back. Both of you can never attend the same, yes, or the same. Maybe you and your sister, you don't ever want to sleep in the same room. If she chooses this room, you are changing room. So that's what mutually exclusive sisters. Brothers can never do that kind of thing. Yes, but with sisters it's very common. If you want to know what it means or what I'm talking about, give birth to girl children. So for mutually exclusive events, they can never be together. It means that probability of 2 events, if A, just write if A, we're writing, and B are mutually exclusive events, then P of A intersection B is 0. Meaning that there's no probability that these 2 events they can occur together. It's okay. Good. So for mutually exclusive events, P of A intersection B is 0. Then also P of A union B is what? P of A plus P of B for mutually exclusive events. Number 3 is independent events.
So I don't understand.
You are not supposed to understand. This is 4. You have understood now?
This is explain the last topic number 3.
This one.
Yes, sir.
What is P of A union B? The probability that either A occurs or B occurs. Given that these 2 people, they are still under mutually exclusive. So here we are still saying that these 2 people, they cannot occur together. So first of all, the probability that both of them occur can never be possible is always 0. But the probability that this one occur, because if I say that the 2 of you can never attend class together, it means that the 2 of you can never be found in the same class at the same time. But also, it means that at one time you can be the one in class, and during another time she's the one in class, and during another time none of you is in class. Right? Yes. So now the probability that either you are in class or she is in class is the probability that you are in class plus the probability that she's in class. This is what I mean here. It's okay now. It's okay now. It's okay. It's okay now. That's the meaning. For independent events, the probability of A intersection B is what? Probability of A times probability of B. So if a question, they tell you that A and B, they are independent events, then that is the meaning. That's number 4. So number 5 now. Number 5. Complementary events. It's going now. Good. So for complementary events, we're representing with a prime. Okay? So the probability of A prime, the probability that a complementary event occurs is what? 1 minus the probability of that event. See, let me explain what I mean here. If the probability that you will eat today is 1/3, even though I know you will not eat, then the probability that you will not eat is what? 1 minus 1/3. That's the meaning of complementary events. If the probability that you will come to school is half, then the probability that you will not come to school is 1 minus half. It's okay now? Yes, that's what complementary events. That's the end of type of what? Type of events. So these are the various type of events that you can have. So now, rules. Or just say probability rules. Number 1, addition rule. Addition rule, that's the first rule. It says that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is a rule, so we don't explain rule. Okay? We use the rule now to solve. So it's when I'm solving, you're asking me that why are you subtracting? I'll come to the rule and tell you that this is why I'm subtracting. Because there are some people, if they tell you that this is how they write 2, you ask me that why is it like this? Nah, so that's why I'm defending myself at once. Multiplication rule. Multiplication rule. Multiplication rule is as simple as probability of A intersection B, probability of A times probability of B. Here we don't subtract. Now, okay, after copying, I'll explain something. We're now going to work free diagram. Meaning that we're almost done. The most important thing in probability is what? The probability formula. Okay? The number of favorable outcomes divided by the total number of possible outcomes. Now let me explain why for mutually exclusive events, probability of A union B is just probability of A plus probability of B, and this one is not there. You notice that under a mutually exclusive, this one is not there now.
Yes, sir.
Yes, why? Because for mutually exclusive event, this is what? 0.
0.
Good. So it's only left this and that, right? Yes.
Sir.
Yes.
Okay. In case you have been asked a question now that concerns the mutual.
I want to do something before free diagram, so that free diagram will last. So I'll just do one thing. Then now I'll end with free diagram. Then I'll now do maybe answer some questions. It's okay now? Yes, ask your question.
So okay, if you have been given a question under mutual exclusive now, then you have been solved, and you apply this formula there. You apply B then bracket A union B equals to B bracket A plus B bracket B minus B bracket A intersection. Do you apply the formula?
Yes.
Then you
come and say this one is 0.
You go.
It's okay.
That means the teacher say I pro now.
Small. Some special probability solutions. Solution to some special probability. Okay. Number 1. Tossing a coin. Now, in the exam, they can tell you that a coin was tossed. And they don't tell you that when you toss a coin, these are the various possibilities that can happen. But they expect you to know. So, you have ever seen coin now?
Yeah.
Yes. So, a coin has how many sides? Two sides. What are the names given to the two sides?
The name that beside that the main money.
The side that's having the main money now,
Yeah.
and the side that's having what? That's not having the main money. The side that's having the main money is called the head.
The head and the tail.
Head and the tail. Then the side that's not having the main money is the tail. It's okay.
Yeah.
Yes. So if a coin is tossed, we have two possible outcomes. Either we have a head or we have a tail. So the probability. So okay, let me just say this. What is the number of what's the total number of possible outcomes? 2. Because it means the sample space is what? 2. You either have a head or a tail, just 2 possibilities. Now what is the probability of having a head? 1/2. Favorable outcome. Because if you toss and you have a hit, it's favorable now. If you have a tail, it's not favorable. So out of these 2 possibilities, one is favorable, one is not favorable. So favorable outcome 1 over total outcome 2, right? Probability of having a tail
It's also
1/2. It's okay. And life is good. So just take this one. The first special probability solution is tossing a coin. Next will be what? Rolling a die.
So I have a small question.
Okay. You can even make it big, we'll still answer.
About when I was doing the registration, I saw that 1,000 had to be paid.
You saw that
That everybody needs to pay 1,000.
where? For the mock?
Yes, sir.
Yes. Now let's continue mathematics first. You did not know.
Now I just ask if we're included or
See. The thing is that anyway, I don't want to talk now. Let's finish it.
Okay.
Before we go to relate that, all right here, have you written exercise? Exercise. A coin is tossed twice. Find the probability that no head. Find the probability that Roman 1. Anyway, let me just continue. Roman 1, no head is gotten. Roman 2, at least one tail is gotten. Yes. Solution. You have a little more time. This coin is being tossed twice. Is it? Finish, right? These are the kind of people that we are looking for.
You are looking for red pen.
Yes, my red pen. My red pen. Wow. Easy. While correcting. Okay, correction. Okay, watch here. A coin is tossed twice, right? So now we have tossed this coin the second time. During the first time, we had only 2 chances, right? We are now tossing 2 times. How many outcomes we have? How many possible outcomes?
4.
Yes. So what are the 4 outcomes? You can have head, 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 tail, tail, head, tail, tail. These are the 4 outcomes. Okay? And? Yes. So now,
When you toast 2 times,
pardon?
when you toast
2 times, yes, 2 times. Now, can we continue? We are finding the probability that no head is gotten. Okay? What's the probability of a head?
1.
1.
No. It's a coin answer.
0.
Yeah.
Possible.
It's one of the possible outcomes.
It's 1 over 2.
No, not 1 over 2. There are 4 possibilities now.
So it's not, you cannot toast it and it comes. It's
You
4.
can toss it first time, it's head. Second time, this here means the first toss and this is the second toss. Okay? Yes. So this is 1 quarter. All these ones, the probability is 1 over 4. Okay? Now the probability that no head is gotten, it means that only tail, no head. Here there's head now, eliminated. There's head here, eliminated. There's head, eliminated. Okay? So the probability of what? No head is what? Probability of what? Tail. Okay? Or in short, probability of what? Tail, tail.
If you write 1 quarter, it's 4.
That's the answer. You have 0 over 4 now. Alright?
Yes, sir.
Now, probability that at least 1 tail is gotten. Okay? Yes, at least 1 tail. So, here now, probability of at least 1 tail. Here is there any tail? Eliminated. Here there's a tail. There's a It's okay. This method 1. We can also do it this way. Probability of at least one tail. Okay. Now, probability, I said something here. I've wiped it already. I said the probability of a complement is 1 minus. So, see what I want to say here. The probability of at least one tail is what? 1 minus the probability of no tail. Okay. You will see that no tail and at least one tail, they are opposite now. They are direct opposite. It's like we can say probability that everybody in this class they are boys. Probability that everybody are girls. So it's direct opposite. That's so in this case we can subtract them. 1 minus this. Okay? Yes. So here will be what? 1 minus 1 over 4. 3 over 4. Same answer. But I prefer you do this, okay? Work is done. So we are now going to 2, rolling a die. You need to also know that you can roll a die twice and thrice. So I'm wiping.
No. 80. 1, 4, 1, 4.
Rolling a die. If a die is rolled, the sample space S is what? 6. If a die is rolled once. Okay? Yes. So now, okay, I already spoke something about it now. So exercise. A die, if a die is rolled, find the probability. That the outcome is bigger than 4. Number 3, picking a card. This is the third special solution to probability. And we'll end with this number 3. We'll just go to tree diagram. We'll talk about probability tree diagram.
This you are solving this one now.
You are solving it now. Are we done?
There's a lot of people there, you know the answer, but you don't know how to do
You know the answer, but you don't know what to do.
it.
No, then you are guessing. That's guesswork.
No, you are not guessing.
It's clearly guesswork. You are guessing it. You cannot know
So
it.
you don't give formula when it's unfavorable.
When it's unfavorable,
Yes.
it's 1 minus favorable. Oh, easy, bube. See how far you bless me. I can see, I can tell, and I know it's your grace. a card a die is rolled. If a die is rolled, the probability that the outcome is bigger than 4, right? Bigger than 4, it can have 5 or 6, right? So there are 2 favorable outcomes. So the number of favorable outcomes is 2. The total number of possible outcomes is 6. So this is 1/3.
Wait.
Now we are going to pick in a card. This is what we must do.
You have been paying the second question before.
There was a question, second question here.
So that's maybe at the morning.
There's only one.
So that's not at the morning.
It's okay. Picking a card. You know how to play card now.
Yes, sir.
To play card, if I buy card, how much are they selling it?
200.
Only 200.
I know that. That's everything.
Okay. If I knew that, if I don't know where I can get it, I would have come along with it so that, because this thing confuses people.
Let me get it up, please.
It's okay. Yes, okay, so that during break people play it.
Yes, sir.
Why they are writing on Saturday?
But if you say if you knew, so you were joking that if you knew.
Yeah, if I knew, but now that I know it's a little bit in it.
So there's a statement that says learning without playing make Jack a dodge.
Yeah, you just play after writing. After writing, you have enough time to play. Okay. Now, a pack of cards has 52 cards, right?
Yes, sir.
These 52 cards, they are divided into 4 suits each. So, and then each suit has 13 cards. So, if you multiply 13 times 4, you'll be what? 52. So, if you open a card, you divide it into the 4 suits. You have 13, 13, 13, 13, 4 places. You have the hearts, 13 hearts, right? 13 diamonds.
13 black cocoa.
Black cocoa?
Is that black one?
Yeah. Which one is black cocoa, club or spade?
Please, I don't know. It should be club.
Spade is that one that has is black in color and it.
No, it's cocoa. That one, yeah,
Then club comes up like this. It's
no.
also black.
It's club. Club.
These two are red.
Yes.
Heart is something, I don't know if you know how to draw heart.
Yes.
Diamond is like this and it's red.
Yes, sir.
Yes. Then this one, it comes up like this. Then this one,
So let me draw it.
Thank you.
it's okay.
I've already drawn it.
Okay. So now, just know that there are 13, 13 here, 13 here, 13 here, and 13 here. Then now, each suit, the 13, this, for heart alone, a heart has 1 jack, 1 queen, 1 king, 1 ace, and 9 cards again. The 9 cards start from, the number cards now from 2. 1 is what? Ace.
Yes.
Then 2, 3, 4 up to 10. The number them. So if you count all of them from the number 2 to number 10, you have 9 cards. This one we call them face cards. Then now we have 1 jack, 1 king, 1 queen, and 1 ace. The same for diamond. We have 9 face cards, 1 jack, 1 king, 1 queen, and 1 ace. All like that. It's okay now. Exercise. So I have questions on cards. I should just get the thing from my friend quickly so that life should be made easy. Right.
Sir,
Yes.
this is a question.
Ask.
That same question that I get for life in that you will find it particular outcome is bigger than 4.
Yes.
It's not the same if the question was less than.
If it was less than is what? 1, 2, 3. Yes, because 4 is not less than 4 and there's no 0 on die. So there are 3 favorable outcomes of our total of 6 possible outcomes. So this makes half. It's okay.
Yes, sir.
Now, from a standard pack of cards, a card is picked at random. Find the probability. Find the probability that it is A. An ace, B, a king, C, a heart. This is the answer. You are just stating it. You are not even solving.
No, so I was still copying now.
You are still copying.
We're not copying.
Hey.
Wanted to pay attention.
Huh? We still have probability 3 to do. And anyway, it's no wala.
What's an axe?
What is
An axe.
an ace?
An ace.
An ace. An ace is one of the cards in a suit now. Look up there, you see ace. That's ace there. Oh, ace. Who is saying come? It's just as if I was too fast. Anyway, it's your problem. Yes, are you done?
No, sir.
Still copying or doing the exercise? Or trying to understand?
No.
going to answer this question for probability diagram, for tree diagram, and we are done. So I'm going to explain the way I've come out with the question, it has everything. So after answering this question on probability, tree diagram, you are born. So which one? That's there was a question here. Okay, you will just read the question. Read the question, please. Read now.
From the standard pack of cards, a card is picked at random. Find the probability that it is an arc. Okay.
An ace, not arc. An ace. A packet of playing cards, the sample space is what? 52. How many aces are there? How many aces? I said there are four. No. Listen. There are 4 suits, right? Each suit has 13. And each suit has 1 ace. Each suit has 1 ace. 1 ace here, 1 here, 1 here, 1 here. So there are 4 aces. And 4 over 52. Next, find probability that is a king. A king. There are also 4 kings. Okay, because there's 1 pair suit. So same thing. Next.
A hat.
A hat. How many hats are there? 13. So it's 13 over. Next. A hat is one of the suits, right? I said out of the 52 cards, right? There are 4 suits. Hats. What again? No. Club, yes. Spade. And what? Diamond. These are the 4 suits. Okay. So each suit has 13 cards. We are done now. We are here now. Tree diagram. Solution. So the probability diagram that came for custom is in your pamphlet. Is it last year?
No.
Probability was last year or year before last. You do it. It's you have to draw tree diagram. You have to answer some questions there. So after this, you understand a lot. A basket contains 4 blue balls and 6 red balls. So this is a basket. Please follow what I'm doing. Okay, this is a basket. 4 blue balls and 6 red balls. From this basket, 2 balls are picked at random. When they say at random, it means just say your hand, you just pick it. You don't send your hand and touch or feel it or try to distinguish it. You just pick. Okay, that's what we mean by random. So, and then you are picking without looking. Now, one after another, it means you pick the first one before you pick the second one. It's okay. Now, Roman 1 with replacement. So we're supposed to do it twice. We're supposed to first of all do with replacement. After you have understood, I will now come back without replacement. So now that's what I've just separated here. These are the questions you're answering, not these ones. With replacement. So we're starting with Roman 1 with replacement. With replacement means that after you have picked the first one and you have found its probability, you replace it back. Without replacement means that after you have removed, you don't put it back inside. Well, I'm going to see the difference. So we're working first with replacement. Find the probability that both balls are blue. So we are going to do selection. Using a probability diagram, we are going to do 2 selections. This is the first selection. These are the branches of your tree diagram. So now, For there are two possibilities. When you pick, you either have what? A blue ball or a red ball. Blue, red. What's the probability of having a blue ball?
4.
There are four blue balls out of how many total? Total 4 balls. Never make a mistake to simplify this. Now, from here, from complementary events, you already know that this is 6 on 10. Because 1 minus 4 on 10 is 6 on 10. Or you also do it, okay? You also do it 6 on 10. Now, this is first selection. Second selection now, we go. Second selection is like this. If there was third selection, we'll continue. So you can have blue, red, you can have blue, red.
So if you are step solution, how will you draw the tree?
It's okay. That's third selection. And you can continue.
If you have the 10th selection.
Yes, so long as you have space. So we are working with 2 selections. Now, here we are working with replacement. So after we have selected this one, we have put it back. So the probability for red is still what? For blue is 4 on 10. Probability for red now is what? 6 on. Probability for blue. We are done there. This is your tree diagram, I have drawn it. Is it difficult?
Please, so in case we were to draw a tree diagram, the question does not precise.
The question?
The question does not say draw a tree diagram.
Most often, where you need to draw tree diagram, they will say it. They will even tell you to draw a tree diagram, and then from your tree diagram, determine this. Sometimes a question like this one, it's obvious you will use a tree diagram. So sometimes when you see that the question needs you to use a tree diagram, you don't need to be told. You will see that even if you don't use a tree diagram, you'll stress more. With this one, you will see how easy it is. When you do a tree diagram, this is what I always do, my own approach, okay? So now, this is what you can always do. When you're done here, this is what? Blue, blue. This is blue, red. Are you seeing it? This is red, blue, and this is red, red. Now, we answer A. Both balls are blue. It means the first ball is blue and the second ball is blue. Meaning that blue, blue. So I'm looking for the probability of what? Blue, blue. Which is what? 4 on 10 times. Are you there?
So why have we multiplied instead of adding?
There is a difference between and, then or. If it is and, multiply. If it is or, add.
There's neither and nor or.
It is and. The first ball is blue and the second ball is blue.
The question said both balls are blue.
Both balls are blue. What does it mean? The first ball is blue and the second ball is blue.
Blue
It's
is
addition,
Addition.
multiplication.
Okay.
And or now.
I'm saying that can you say that? Okay, let's understand now. If I say both balls are blue, can you come in front and tell me that it is either this one is blue or this one is blue? Because when you're saying or, it means either one is blue or the other one is blue. But both means the two of them are blue. Meaning that if I say all of you are girls, it means you are a girl, and you are a girl, and you are a girl, and so on. My interest is that and there. Because it is what tells you whether you are adding or multiplying. You thought it's adding in mathematics. Okay, you people should add.
No, sir, just to clarify my doubt. And
let me say this.
This way you are standing like that is hiding.
Pardon.
It's hiding where you are standing and hiding.
This one is hiding or this one?
You are standing here now.
Okay. The question was what?
Both balls are blue.
Both balls are blue. Let me say, if I have two sets, okay, set A, 2, 4, 6, set B, 1, 2, 5, okay, how do I represent this? That 2 is found in both sets.
Intersection.
Intersection. And intersection in math means what? And. Okay. So, okay, let me go. Let me continue. You people haven't seen your time.
So, no, so just
You're wasting your time.
nonsense. Something we should understand. We studied
One cram
And is in probability and multiply.
this.
one cram it like that.
So that and it's multiply now.
Yes.
Uh-huh.
And then or is to add.
Or add. Okay.
Okay, sir.
You will see it here. In fact, this is how you should know it with probability. Yes, ask a question. Ask it.
So we said in probability.
In fact, in mathematics. When I was doing mutually exclusive, independent events, you saw me adding at some point, multiplying at some points, right? And I was explaining, if they say mutually exclusive, it means these two events cannot occur together. So it is either this one or this one. You saw me adding. Then now when I come to the probability of A intersection B, you see me multiplying. No red ball. No red ball. It means only blue. Okay, it means only blue. Okay, we have done that. No. Wait. Both balls are blue. Now, no red ball is the same thing. The probability that there is no red ball is the probability that there are only blue balls. Tell me you don't understand.
No, you understand.
The probability that there is no girl in class is the probability that everybody is boy. At least one red ball. So it means when you hear at least one red ball, it means it can be one or more. We should not have a situation where there is no red ball. So at least one red ball. This one is off. We have red, blue, red, fine. Red, blue, fine. Red, fine. So this is what you do now. Please look at me very well. At least one red ball. The probability of at least one red ball is the probability of
4 on 10.
blue, red. Please just wait first.
Blue, red.
Plus probability of red, blue. Plus probability of red. So this is what blue, red is 4 on 10 times 6 on 10. So you do 4 on 10 times 6 on 10 plus, this is all, okay?
Yes.
Either it is blue, red, or red, blue, or red, red. That is why you see adding. Red, blue, 6 on 10 times 4 on 10. And red, 6 on 10 times 6 on 10. It gives you an answer.
You said
At most, yes.
you said we don't simplify.
No, your answer you can simplify. But at the level of the tree diagram, don't simplify. You can simplify this one. at most one blue ball. It means that the highest number of blue ball is 1. But here, let me say something again. Since you put the 1.
So if you are right outside around, you'll mark it wrong.
So now, the probability of at least one red ball, that is seen at least one red ball, is 1 minus the probability of no red ball. It's okay. The probability of at least one red ball is 1 minus the probability of no red ball.
Wait, say it again.
Probability of at least one red ball, right? Is equal to 1 minus the probability of no red. It's okay. Oh, it's not okay. It's okay. Now, at most one blue ball. It means that either no blue ball or one blue ball. At most, meaning that the highest number of blue ball you can have is what? 1. So this one, at most, then this one goes with the same probability with this. The same answer with this one. Without replacement. Now, without replacement, now without replacement, listen. Without replacement, it means that after picking, you have not put it back. So I'm going to clean the field diagram and then we'll build it up now without replacement. So here we go. Without replacement, first selection, the probability for a blue is 4 on 6. Sorry, 4 on 10. Probability for a red is still 6 on 10. The difference comes from the second selection, third selection, and so on. Now, the second selection, if the probability now for a blue, if the first ball was a blue, for a second blue, it means there were how many blue? 4. Now, if one blue has been removed, how many blues are left? 3. And how many balls are left in the basket?
9.
Now, how many reds are still in the basket? 6. Now, if the first ball was red, how many blue are in the basket?
4.
It's still 4 on 9.
9.
On 9, yeah. If the first ball was red, the probability for a second red is what? 5 on
9.
good. This is the only difference with replacement and then without replacement. The difference is at the level of the tree diagram. After tree diagram, solution remain the same. Questions?
This was questions to try. No, please, I was not understood.
You are not better talker. Better story.
Exercise. Exercise. Basket A.
Okay.
Wait. Bag A. Done. contains three yellow slots and 5 red slots. Basket B, okay, bag B. Bag B contains 4 yellow slots and 2 red slots. A ball, a slots is picked at random without replacement. No, it's just one slot, so obvious. At random, find the probability that Roman 1 it comes from bag A. Roman 2 the slot is red. Roman 3 the slot is yellow and comes from bag B.